Okay, this is the first STAAR Skills Builder activity, and we will go over all of the questions in fairly quick succession. So for this activity, I will show, when possible, the use of the graphing calculator, but some of the questions don't require it. Let's start with the first question. Number 1. Write a linear inequality in two variables for the following scenario. Coach Trammell wants to purchase some baseballs and gloves for the players on his team with a budget of $2,500. If each baseball costs $14 and each glove costs $30, which inequality represents all the possible combinations of X baseballs and Y gloves? So the way we approach problems like this is to kind of write down the linear inequality as we read the question. And we have to keep one thing in mind. And it's something that we can fix later if, we don't follow this instruction right from the get-go. But they want baseballs to be denoted by the variable X, and they want gloves to be denoted by the variable Y. Now you may find it easier to use a letter like B for baseball and G for gloves, and we can do that. I'll show that both ways. But let's just read through this question one more time, the part that starts after the colon here. Coach Trammell wants to purchase some baseballs and gloves. So we know that our two variables are baseballs, which, like I said, we can denote with B, and gloves, which we can denote with G. All right. Baseballs and gloves for the players on his team with a budget of $2,500. So we know that something is going to happen, and there's going to be a 2,500 over here. And that's all we know. So let's go on to the next sentence. If each baseball costs $14, all right, let's stop there. So what it's telling us is that baseballs cost $14 each. Okay, so if you want to know the total cost of all the baseballs you're going to buy, you multiply the number of baseballs, B, by the cost of just one baseball, which is $14. So we can put 14 in front of the B, and that's 14B. So if each baseball costs $14, we've represented that bit of English sentence right here, and each glove costs $30. So we're saying that, however many gloves you buy, each one's $30. This is our setup. And the English word "and" here is giving us the indication that if we're shopping for baseballs and gloves, we're going to need to add the total cost of the baseballs and the total cost of the gloves. And what it says is here, this is the tricky bit, we have to write an inequality that represents this, because Coach Trammell has a total budget of $2,500, which we've represented here. Now, we have to choose an inequality symbol that shows us that we can buy any mixture of baseballs and gloves such that the total does not exceed $2,500. So this language does not exceed, or total budget of, requires the use of the less than or equal to symbol. In other words, when you go shopping at the store, you've got $2,500 in your pocket. You can spend $2,500 total. So that includes the $2,500. That's why we're saying less than or equal to. So if you've only got $2,500 in your pocket, you can have the number of baseballs and the number of gloves however you want to arrange that. So where baseballs are $14 each and gloves are $30 each. And so that's kind of it's not much more complicated than that. The only hiccup here is that instead of using B for baseballs, they want us to use X. All right, so you have to pay attention there. So we'll rewrite this inequality, 14x plus, and then the glove we have to represent with y, so 14x plus 30y is less than or equal to $2,500. So when we're looking in our answer choices, this is what we're trying to find. So let's look here. Our first answer choice is 14x plus 30y, so far so good, less than 2,500. Well, he could spend $2,500, and what this less than symbol is saying is that he could spend up to the number just preceding 2,500, but he can't spend 2,500. So that's not correct. Let's skip C for just a minute. Let's look at B. 30x plus 14y. Well, that has the correct numbers there, but it says in the problem that X is for baseballs. And we set up here that baseballs are $14 each, but what B is telling us is that baseballs are $30 each and gloves are $14 each. So B can't be right because it's mixed up the costs with the baseballs and gloves. It's actually switched them. So that's not right. Let's look at D. Again, they've made the same mistake. They've mixed up the variables and they've assigned the costs per thing to the wrong variable. So it's not D. By process of elimination, we know we're right with C. And indeed, C shows that, 14 times the number of baseballs plus 30 times the number of gloves is less than or equal to 2,500. So the answer is C. Let's move on to number 2. Okay, number 2. Jasa wants to purchase pencils and rulers for the students in her math class. If each pencil costs 10 cents and each ruler costs 50 cents, which linear inequality represents all the possible combinations of X pencils and Y rulers Jasa can purchase if her spending limit is $25? All right, so once again, we got to break this English sentence down into math. So let's skip looking at the answers for just a minute and think about this. Let's think about it using some English letters or some English substitution letters, and then we'll put this X and Y business in at the end. So it says here, Jason wants to purchase pencils and rulers. So that means that our two variables here are P for pencils and R for rulers. And the total spending limit is $25. So again, we know that something's going to happen and it's not going to go over $25. Now, this is where this type of question can get a little difficult. It says each pencil costs 10 cents. Now, it might be tempting to put a 10 in front of the P, but that would be wrong. It would misrepresent what's being asked. So this is where actually writing in the dollar signs and symbols can help. So what we're talking about money here, guys. So when we say that something costs 10 cents in terms of dollars, we need to represent 10 cents as 1/10 of a dollar. And that's why we say 0.1. That's where that's coming from. That's a dime. If you have 10 of those, you have a dollar. So 0.1 P, because each pencil costs 10 cents. Right, now there's that and again, so it's plus. And then each ruler, according to the problem, costs 50 cents. Resist the temptation to write 50. Instead, think of 50 cents as half a dollar, 50% of $1, or 0.5. Okay, times the number of rulers. Okay, so far so good. So when you're at the store, if you have $25 in your pocket, you can spend up to and including $25, but you can't spend any more than that. So up to and including a number is given by the symbol less than or equal to. So we're kind of done, except for the fact that we have this last clause that says we have to say pencils are X and rulers are Y. So just like the previous problem, we'll change these variables. 0.1 x for pencils plus 0.5 y for rulers. Okay, nothing changes about the inequality symbol, and we put $25. So to flesh this out entirely, we can write the dollar signs here. And that's not showing up very well, but this is kind of what we're looking for in the answer choices. So let's look at well, let's skip the first answer choice because that looks kind of like what we did. Let's see what's wrong with B. What they've done is they're saying 0.5x. Now x means pencils, and this is wrong because 50 cents was the cost of a ruler. So they've switched the cost and the variables here. So B is wrong. Let's look at C. 0.5x and 0.1y. They've done it again where they've switched up the variables, but also they've put the wrong inequality symbol there. They've put a less than sign when they should have put a less than or equal to sign. So C is wrong. Now let's look at D. Here they've actually got 0.1 with the right variable for pencils, so 10 cents per pencil plus 50 cents for ruler, but then they've got the wrong inequality symbol there. They've got less than $25. Remember, Jasa could spend up to 25, including 25. Okay, so up to and including, it's important. So D is wrong, just because that inequality symbol lacks that equals bar. So that leaves us with A, 0.1x plus 0.5y is less than or equal to 25. In other words, when she's shopping for pencils and rulers, she can buy any combination here of pencils and rulers so long as the total cost does not exceed $25. And that's why A is correct. Okay. Now we'll look at number 3. Which coordinate pair is in the solution set of 6x less than or equal to 9y plus 18? Now, okay, so this question is going to require us to graph some things. But before we can graph anything, we have to get this inequality in the form that can be graphed. All right, so right now it's all jumbled up. So we need to manipulate this algebraically. 6x less than or equal to 9y plus 18. Okay, so my objective, okay, and your objective is to get y by itself on the left side of the inequality sign. And everything else needs to be on the right side. So we just have to do some quick manipulations. First, we need to get the 9y from the right side to the left side. And we do that by subtracting 9y from both sides. All right, on the right side, 9y minus 9y gives us 0, so we say that cancels out. And then I've got over here, I've got negative 9y plus 6x is less than or equal to 18. Okay, we're not quite done. So now we need to move the 6x to the right side of the inequality. So we'll subtract 6x from both sides. On the left side, that cancels out, and we're left with negative 9y less than or equal to negative 6x plus 18. All right, so now we're going to do something that requires us to flip the inequality symbol. And what we're going to do is divide every term in the inequality by negative 9, because what we want to do is get rid of the negative 9. Remember, my objective is to get y by itself. So what I'm going to do is divide negative 9y by negative 9, negative 6x by negative 9, and 18 by negative 9. Okay, so on the left side, those negative 9s cancel out, and voila, we've achieved our goal of getting y by itself. We're not quite done yet because we need to remember to flip the inequality symbol because we divided by a negative. All right, so this is important. It's so important that I want to highlight it. You have to flip the sign because you divided by a negative. So we'll say flip the sign from less than or equal to becomes greater than or equal to. All right, so y greater than or equal to negative 6x over negative 9. And then we have this convoluted thing plus 18 over negative 9. Now I think you'll agree that this is not an ideal form for the linear inequality. In fact, the form that we're looking for closely resembles the slope-intercept form, which in our case with the inequality symbol is going to be y greater than or equal to mx plus b. It's important to note here that m can be negative and b can be negative, so this plus symbol might change and there might be a negative sign go in front of the m or not. But that's the form that we're seeking, all right? Because this is a form that we can graph, and we're going to need to graph to finish this problem. Okay, so at this point I kind of need to rewrite to continue, so I'll just move my problem up here, create a little space for me to work in, and I'll just rewrite what we wrote down at the bottom left. Y greater than or equal to negative 6 over negative 9 times x plus 18 over negative 9. So it's time to simplify, reduce, get rid of unnecessary negative symbols, and so on. So let's rewrite y is greater than or equal to, and then think about what we can do here. Now we have a negative divided by a negative. That's going to give us a positive. So we know it's going to be positive 6 over positive 9. Now, can 6/9 be reduced? Well, yeah, it can. There's actually, you can divide both the 6 and the 9 by a common factor, and the greatest common factor that you can divide both by is 3, because if you divide 6 by 3, you get 2, and if you divide 9 by 3, you get 3. So negative 6/9 can be reduced to positive 2/3. The x comes along for the ride. Nothing happened to him. And now we have this weird expression right here, 18 over negative 9. Now the simple solution here is to think, can I divide 18 by 9 evenly? And yeah, you can. If you just take your calculator and divide 18 by 9, you get 2. So 18 divided by 9 is 2, but I've got this negative symbol. So it's actually negative 2. 18 divided by negative 9 is negative 2. So we'll write negative 2. Now I have my linear inequality in slope-intercept form. So in slope-intercept form, I know that my slope is 2/3. This is the slope. If I was going to graph this, my rise over run would be rise 2, run 3. And my y-intercept, okay, is negative 2. So now it's time for me to graph. And if you have graph paper, that's fantastic. I have some graph paper here that we can use to graph this linear inequality. Let me just move this for a moment. Okay, remember my linear inequality is y greater than or equal to 2/3 x minus 2. So I want to graph that. I'll do this on paper and then I'll see what we can do on the graphing calculator. But here's a quick graph. Okay, vertical line is the y-axis. And make sure you can see all this. So here is the x-axis. Okay, here's the x-axis right here. And there's our origin point, 0, 0. So in order to graph a linear inequality, if you remember, what we do is we go down. Maybe I should label these because you probably can't see them very well. This is 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, -4, and so on. So here I am, and what I need to do is find the y-intercept. The y-intercept is -2, so I'm searching for 0, -2. So here's my y-intercept, okay? And I'm going to graph this with the knowledge that I have a greater than or equal to sign. Greater than or equal to is very important. Greater than or equal to, that symbol means that I'm going to have a solid line and that my shading will be done above the line. So keep that in mind as we graph. So we can fill in this point at 0, -2. Now, to graph this linear inequality, we use the slope 2/3 in the terms of rise over run. So rise 2, run 3. That means go up 2 and then over to the right 3. Okay, we can dot a point there. That's a point on the line at 3, 0. And then we go up again, 1, 2, over 3, 1, 2, 3. And there's another point. So now we can use a straight edge. Be very careful as you line this up and then draw in your line. So there is the line. It's a solid line because we have that greater than or equal to sign, and now we need to shade above the line. All right, so I'll choose a color that I can still see through. I'm going to shade above the line. That means I'm going to shade all this. I know the graphing calculators has an app on it that can do inequality graphing, but a lot of times your calculator in test mode will disable the apps, so you cannot rely on that app being there. So, having this skill, I want to be careful that we include the line. Having the skill of hand drawing a graph can be invaluable when you're trying to solve these out in the real world. Okay, that should be good enough. So now what? Okay, we've drawn our inequality. Looks cool. The question asks us which coordinate pair is in the solution set for this inequality. And we're given coordinate pairs. So we actually have to use the answer choices and check them one at a time. What this question is asking us to do is plot each of these answer choices and check to see if it's in the shaded region of the graph. All right, so the key point is the point in the shaded region of the graph. So the first point is -3, -9. All right, so let's check that out. Here's -1, -2, -3 on the x-axis, and now let's go down to -9. -1, -2, -3, -4, -5, -6, -7, -8, -9. Now I'm actually off the camera. Let me just show you where that point is. Point's way down here. So it's clearly below the graph. Okay, it's below the shaded region. So that answer choice A, that cannot be correct. All right, let's look at answer choice B, 0, -3. So that's x is 0, y is -3. So let's graph that point. X is 0, y is -3, -1, -2, -3. There's that point right there. Again, that is not in the shaded region of the graph, so B as an answer choice can't work. Let's look at D. 3 comma negative 2. All right, let's go over to 3. 1, 2, 3. And then go down to negative 2. Negative 1, negative 2. So once again, that point is not in the shaded region. So that's not our answer. So D is wrong. Oh. Let's double check to make sure that C is in fact the correct answer. 2 comma 3. So here I've got 2 on the x-axis and then up 3. 1, 2, 3. So that's the point 2 comma 3. And that point is in the solution set or shaded region of our graph. So that's how we know that 2 comma 3 is the correct answer. Okay? So, if you wanted to graph this using the graphing calculator, you could, but there again, you might not have access to this shading feature. So I want to make sure that that you know how to do this by hand, because the graphing calculator, if it's in test mode, may deprive you of access to that cool inequality graphing application. Still, I will try to show it. So we'll go to our display here and take a look at this cool emulator, this TI-84 plus CE emulator, and we'll see what we can see. All right, so what we're going to do is let's just check and see if that inequality graphing application is on this emulator. So I'll click Apps. Okay. And then it says 7 is inequals. So we'll use the cursor to go down to 7 for inequals. Hit Enter. Okay. And now we're here in the inequality graphing utility. Now, your calculators actually do this a little bit differently. So again, I hesitate to show this, but I'll show it anyway. We actually want to change the symbol that we're using. So I think for this particular version of the calculator, we want to hit Enter here. Maybe not. Maybe I want to hit Enter on this. Yep. Okay, so for this calculator, we want to go down here and then change this to the symbol greater than or equal to. Okay, it's showing it's going to shade above. Okay, we can actually change the color to more closely match what we actually drew. Let's see if it has an orange. Cool. So we'll go to here, click OK. All right, now we have that done, and we can just type in our the inequality that we were given, which was 2/3 x minus 2. So if you really want to type this in to look exactly like what we solved for, you can hit alpha y equals and then hit Enter for n over d notation. Okay, and so now we need to click 2 for the numerator and 3 for the denominator, and then hit the right arrow, put an X there, and then hit minus, and then 2, right? We go up here to graph, and you'll see that graphed right there. Okay, so if you wanted to, you could take a look at the graph and see that 2 comma 3, which would be right here, and then up 1, up 2, up 3, is in the solution set of the linear inequality. Okay, what if you didn't have access to the linear inequality calculator application? Well, you could still graph this. Here, let me clear the memory. 2 plus 7, 1, 2. Okay, clear the RAM. Go to y equals and just type in the equation for the line. All right? So in this case, we'll type, again, we're going to do alpha y equals to get that n over d notation, and then 2 over 3 x minus 2. Okay, now we'll graph this. So see, we don't have the shading anymore, so you kind of have to know that greater than or equal to is going to shade above that line. All right, so that's something to keep in mind. Now there again, you can look and see which points will fall in this area right here. And then I guess as a final way of checking this, you can go to second graph and look at the table, and you should find that the point 2, 3 is in the, well, this is just going to show points on the line. So this is going to be a bad example. So it looks like the table is not going to be a solution here for us, but we can kind of triangulate it. So when x is 2, it's saying any y value greater than negative 2/3 is going to be in the solution set. Greater than or equal to negative 2/3 is going to be in the solution set. So we had 2, 3, and that 3 value is in fact greater than negative 2/3. So back on the graph, we see 2, 3, about right there, is definitely in the solution set. So that's probably good enough for the calculator here. Let me clear the memory. Second plus 7, 1, 2. Okay, just set it up for the next problem, and we'll transition back to our work surface. Okay, so that's a long, drawn-out solution to number 3, but I think it's important that we show all the different ways to kind of solve this answer. There's really no way around fixing these variables so y is by itself. I mean, if you're not able to get there, then you're kind of stuck. So that's why this bit of algebra is so important. Okay, moving on. Number 4. The graph of 8x plus 4y equals 12 is shown below. So there, they've kind of done what your graphing calculator can do. They've shown you the graph of a line. Which ordered pair is in the solution set of 8x plus 4y less than or equal to 12? Okay, so here we have to do the same thing. We need to get y by itself. In this case, they're presenting us with the equation of a linear inequality in standard form, and we need to convert it into slope-intercept form. So we can do that using algebra. 8x plus 4y less than or equal to 12. All right, so to get y by itself, subtract 8x from both sides. On the left, it cancels out, leaving 4y by itself, then less than or equal to negative 8x plus 12. Okay, now we're going to divide every term in our linear inequality by 4. Now doing this does not require us to flip the inequality symbol because 4 is positive. I can cross these out on the left, leaving y by itself. So y is less than or equal to negative 8 over 4x plus, what's 12 divided by 4? Just 3. So what I did was I divided 12 by 4, and that gives me that 3 right there. Okay, so this is the linear inequality expressed right here. The reason we had to solve this is to make sure that we didn't have to flip that sign. So they've actually already given us the line, and it's a solid line because this is less than or equal to. The question is, where do we shade? Do we shade above the line or below the line? Well, less than or equal to, we're going to shade below the line. So here I'll shade below the line. That means that our inequality can take on any value in this shaded region, including points right on the line. And that might be important in this problem. Okay. So let's check our values now. Let's skip A for a second. Let's look at 0, 4. So let's go to 0 right here and then go up 4. 1, 2, 3, 4. Actually, want to use a different color here. So there's that point 0, 4. And do you see how it's above the line? So it can't be 0, 4. Sorry. Now let's check 3, 6. So here we're going to go over to the right, 1, 2, 3, and then up 6 right there. Okay. Yet another point that's not in the shaded region, so it can't be 3, 6. Finally, let's check 4, 2. Here we go, starting at 0, go over to 4, and then up to 2, right there. Okay, yet again, it's not in the shaded region, so it can't be 4, 2. All right, so we're pretty sure it's A, but let's double check. We're going to go up. We're going to go, starting at the origin, we will go over 3. That's over to the right 3. 1, 2, 3. Okay, so we're right there. And now we're going to go down 3 because it's the y component of the coordinate is -3. So we'll go -1, -2, -3. So this is important. You see how I just circled in a little red dot right on the line? Well, you could say, well, that's not in the shaded region. Well, yes, it is, because less than or equal to includes points on the line. Okay, so that's a valid point right there. So in this case, the answer is A. That is in the solution set of the linear inequality. Okay. Finally, we're looking at another linear inequality question. Which graph best represents the solution set of 2x less than 27 minus 3y? Well, finally, we've got a less than symbol, so we know we're going to be dealing with a dotted line. And fair enough, all of the possible answer choices are dotted lines. But, you know, which way is the slope going and where do we shade? Well, that's something we're going to have to figure out. So let's take, again, here's our goal. Our goal is to get this y on the left side of the inequality symbol by itself. We're going to have to do some manipulation. So we're given 2x less than 27 minus 3y. So it's time to go to work. The first thing we can do is add 3y to both sides. And that pulls the y over to the left side of the inequality. Okay, on the right it cancels out, and that I'm left here on the left side with 3y plus 2x less than 27. Okay, so now I want to subtract 2x from both sides to move the 2x to the right side of the inequality. This cancels out right here. Now I've got 3y less than negative 2x plus 27. Okay, am I done? No, because I still have a coefficient in front of the y. So what I want to do is divide every term in this linear inequality by positive 3. Okay, I don't have to flip the sign because 3 was positive. So the 3's cancel out over here, and I've got y is less than, okay, negative 2 over 3 times x plus, now 27 over 3. 27 divided by 3 gives 9. So we can just write 9. So now we're ready to rock and roll. We have our linear inequality in, slope-intercept form. And because it's a dotted line, I just gave the game away, because it's a less than symbol, Okay, we know we're going to have a dotted line, and we're going to shade below that line. Okay, so we need to keep that in mind. All of the answer choices are dotted lines with shading below the line, so that doesn't help us much. The next thing we can look at is that we have a negative slope. See, it's negative 2/3. Okay, so that means that the slope is going to be going down the mountain. So it's going to be pointing down. Since we have a negative slope, we can automatically eliminate A and B. It's hard for you to see all the answer choices. See how C and D point down, and point down, and A and B point up. So we can get rid of it right there. You know, if you weren't thinking about the slope, the other way you could look at it is look at that y-intercept. It needs to be 9. Well, let's look at this first y-intercept. It's hard to read, but that's a 20. And that's a 27 y-intercept right there. So again, this can't be right because the y-intercept needs to be 9, not 27. So that's again wrong, double wrong. Okay, not looking good for A. Now look at B. Here's a y-intercept of -9, not +9. So again, that's wrong, double wrong for B. Let's look at D. All right, D has a negative slope, and it's a dotted line, but the y-intercept is -9, not +9. So not good for D. Now let's look at C. What we're looking for is a slope of a y-intercept of +9 and a negative slope, negative 2/3. So we do have a y-intercept of 9. So that's enough right there to stop working, but we can double check the slope. Starting at 9, if we go down 2 and over 3, we should arrive at a point on the line. It's really hard to do, but if you go down 2 visually, okay, and over 3, you'll hit that line. So, but right there, that was enough information to know that C is the correct answer choice. All right, and just for fun, I will jump to a regular graphing calculator. I know these are hard to see on this screen, but I'll go to y equals. I better turn on that app, inequalities. Okay, and for me, I've got to change mine to a less than symbol. Okay, so y is less than, and then I'll do alpha y equals -2 over 3 x plus 9, and I'll graph that. Oh, I see I've got a whole bunch of stat data. I'll have to get rid of that. Go back to y equals and turn that statistical plot off. And then I need to reset my window. Okay, let me just zoom standard here. Okay, let me zoom out 1 so you can see the whole thing. And that's showing us the inequality graph, downward sloping. And the reason they're different, they look like they're different angles, is because my window is different. I could try to mimic this window by going to window and then setting the dimensions, x min -20, x max 20, y min -20, y max 20. We'll see if that doesn't help us out at all. Yep, just confirming that the shading is right and we've chosen the right answer. Okay. And that brings us to the conclusion of Builder 1. Okay, so here's the thing, guys. This was a 5-question assignment. If there's anything that you didn't understand in this assignment, or you were shaky about, or you guessed on, it is super important that you scrutinize this video and that you try these problems over and over again until you feel like you can solve them without the aid of a teacher. Because when that STAAR test comes along, you'll kind of be in there with whatever wits you have. So I hope this was helpful, and we'll try to keep doing this. But for now, we'll end the video, and thanks for watching.